I am Anil Kumar. Welcome to my series on indefinite integrals. So we have shared with you 4 examples each related to these 5 formulae in the previous section. Now it is time to have a small quiz. So we'll have again 4 questions for you. And in those questions we'll use the above formula. Plus you should also remember the logarithmic functions as such. Related formulas are given here for your reference, correct? Let's move on and share the questions with you. So we have 4 questions here. The very first one is integral of 3 e to the power of x 5 to the power of x dx. Now these 4 questions, basically the integral of a to the power of bx plus c dx can be used to solve these questions, more or less, right? Now we may have to use some identities which you learned in logarithms or the rules learned in logarithms to solve these questions. I'd like you to pause the video, copy these questions and then answer. Here are my solutions. The very first one here is integral of 3 e to the power of x 5 to the power of x dx. You could rewrite this as integral of 3 is a constant, so I prefer to write constants outside. So it kind of simplifies our expression. So we get e to the power of x and 5. Both are to the power of x. So we could write this as 5e to the power of x dx. Does make sense. Correct? Now 5e is like a, right? It's kind of constant. E is a constant. 5 is also constant to the power of x. And therefore we can use this particular formula to find the integral. So what we get here is 3 times. Here we have 5e to the power of x divided by ln of 5e, right? ln of 5e. So that is how we can find the integral of this particular example, plus c, the constant, of course. The next one here, we have base as e and the power is to ln x. ln x is also to the base e. So let's rewrite this integral also. So we have e and we have ln x square, right? x square dx. Now e and ln are inverse of one another. So what we get here is integral of x square dx. Perfect. So integral of x square dx, we can use our formula number 1, which is x cubed and then divide by 3. So 1 over 3 x cubed plus c. Does make sense to you? So it may look like a different formulas, but when you solve or simplify it, you see it changes, right? The next 2 we'll take it on the next page, right? We have also provided you with the hint so that these are the formulas moving forward. You should always remember. Now here is part C. You need to find integral of 3 ln x dx. Now 3 ln x dx can be written as what? Now here the power is e, right? Ln is log to the base e of x. You could actually rewrite this and you could write this as x to the power of ln 3 dx. So we have used this particular logarithmic rule to rearrange. X to the power of log ay is equal to y to the power of log ax, correct? Now, so x and y can be interchanged. You can see that. So we interchange 3 and x. So you can write this as x to the power of ln 3. So we could write this as integral of x to the power of ln 3. Now ln 3 is a constant, so we can use the power rule, correct? So we can now write this as x to the power of ln 3 plus 1, right, divided by ln 3 plus 1 plus c. Do you see that? So that is kind of tricky. So in such cases, you have to think and then work out. Perfect? We don't have any formula for a to the power of ln x, right? We have a to the power of x. Do you see that? So if you have a question which is like this, you need to rewrite and then figure it out. Similarly, in part D also, we need to do some work with the logarithmic function, and therefore we have given you a hint, which is log to the base b to the power of nx equals to 1 over n log to the base b of x. So let's try to understand this particular rule. So the integral here is 2 to the power of log to the base 8x, correct? So what I can do here is, we may change this base to 2, right? So we can get this as log to the base 2 of x divided by log to the base 2 of 8. Do you see that? So we change the base. And now what does it look like? Let's see. So we get integral of 2 log to the base 2 of x. We have log to the base 2 of x divided by log to the base 2 of 8 is what? 8 is 2 cube, right? So it is 3. Since, let's do it on this side. So we know log to the base 2 of 8 is equals to log to the base 2 of 2 cube, right? Which is equals to 3. So we wrote this 3 here. Is that clear to you? Correct? So now you could write this as integral of 2 log to the base 2 of, this is 1/3, right? So cube root of 3, right? X to the power of 1 over 3 dx, correct? Now 2 to the power of log 2, they become inverse of one another, and therefore the function is x to the power of 1 over 3 dx. There again we can apply the power rule and find the solution, right? So x to the power of 1 over 3 plus 1 divided by 1 over 3 plus 1 plus c. That is the answer, right? So 4 over 3 and 4 over 3. Now we could write this as 3 over 4 here. That is in the denominator, 4 over 3. X to the power of 4 over 3 plus c. Does it make sense to you? That is how we will actually solve this particular question. So do you see, even using the simple integrands, we may land up with some complications. So you need to review a lot about logarithmic functions moving forward. So I hope with this you have a good review of how to use these 5 basic formulae to find the integrals. Now we'll move forward and in the next section we'll take up trigonometric integrands and work with some rational functions. I hope you find it interesting and useful. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.